solving trig equations using radians. The basic rules for solving equations with sine, cos and tan are these. These are basically summaries of the symmetries that you see in the graphs. So for an equation involving sine x, x is the initial angle you get from your calculator. You do 180 minus that angle, and now you've got two angles. And then from both of these two you can do plus or minus 360 as many times as you like. And you stay within a given range when you're solving a problem. For cosine, the first angle you get from your calculator, so when you do cos inverse of something, the first angle, and then you just change the sign on that angle. Again, that's because the cosine graph is symmetrical about the y-axis, so we're just using symmetries. And then from these two angles you can add or subtract 360 degrees as many times as you like, again staying within a given interval. And for tan, you get an angle from your calculator, so you do tan inverse of some ratio, and from the angle that you get you can add 180 or subtract 80 as many times as you like. And I will demonstrate this with a few examples, but first we need to change these into radians. So wherever you see 180 we replace with pi, and where you see 360 replace with 2 pi. So we have these. So first example, we're using sine x and degrees, and then I'll do the same example in part B in radians. Okay, so here are the basic rules for sine. So from the calculator, sine inverse or arc sine of a half is 30 degrees, so that's my initial angle, and then I need to do 180 minus that angle, so 180 minus 30, so now I've got 150 degrees. And then from these two angles I can add or subtract 360 as many times as I want, but I need to keep within this interval. And I've also checked that the angle here in the equation and the angle here in the interval are exactly the same. If they're not the same, don't do anything to this, leave that as it is, but you need to modify your interval so that this is the same as what you see here. So as an example, if that was sine 2x, to get 2x here I would times 2 here, here and here. Work out all my angles, and then the last step would be to divide by 2 to work out x. So if I subtract 360 degrees from 30, I get minus 330, and that's within the interval, so that's a valid angle. But if I add 360 to the 30, I get 390, and that takes me outside this interval, so I don't want that angle. Now the 150 degrees, if I subtract 360, I get minus 210, that's within the interval, that's a good angle. If I add 360, it will take me outside the interval, so I don't want any of those angles. So these are the angles in degrees, and we can take any one of these and convert to radians. So minus 330 degrees times pi over 180 will give minus 11 over 6 pi. This is the exact angle in radians. This is a rounded angle in radians. So these are the angles in radians. Now in part B we're going to put the calculator into radians mode and do everything in radians from start to end. Okay, so let's change the mode to radians. Okay, we're in radians mode, so sine inverse of half, 1/6 pi. So for my second angle, it's pi minus 1/6 pi. So pi minus the previous value, 5/6 pi. Now from these two angles, from these two, I can add or subtract 2 pi as many times as I want, but I need to keep within this interval. Now when you have mixed numbers like 2 and 4/5, the 2 and the 4/5 are not multiplied, you're adding them. It's 2 plus 4/5. When you have 1/6 pi, it means it's 1/6 times pi. It may look similar to this mixed number format, but it's not. We're not doing 1/6 plus pi. We're not adding them, we're multiplying them. So I'm going to start with pi over 6, or 1/6 pi. I'm going to subtract 2 pi. Subtract 2 pi. Now, I've got minus 11 over 6 pi, which is a little bit awkward when you try and compare it to the interval here. So what I would recommend doing is press the SD key and look at the like the rounded value, the decimal value, and it would be useful if the 2 pi and the minus 2 pi were written in their decimal forms as well. So 6.28 minus 6.28 radians. Okay, all I've done is I've put 2 pi in the calculator, hit the SD key, and it's about 6.28 radians. It helps when you're comparing angles that you've worked out to see if they're within that interval. So this angle, if I just press the SD key, it's easy to compare now. Minus 5.76 radians is within the interval here, so that's a good angle. I want this, and I want to write it down in its exact form. If I add 2 pi to 1/6 pi, so if I'm doing this, adding 2 pi, it will take me outside the interval, so I don't want to add 2 pi here. Okay, moving down to my second angle, which was this. It came from pi minus x. So I'm going to subtract 2 pi. There we go. And again, if I press the SD key, minus 3.66 is within the interval here, so that's a good angle. I need to write this one down. So minus 7 over 6 pi. And if I add 2 pi, 17 over 6 pi, press the SD key, 8.90 radians. It's more than 6.28. It's outside the range. I don't want that one either. So these are my angles in radians, and you'll see they are exactly the same as what we worked out previously when we used degrees and then converted the degrees to radians. Now this method is okay where you work in degrees and then convert to radians at the end, but you must get used to working with radians right from the offset. What you'll find is when we do calculus, so differentiation and integration using trig functions, they are all done in radians and not degrees. So get used to using radians everywhere.